Right, hello again. Here we're going to derive the formula for the volume of a sphere. I'm going to start off by drawing a hemisphere, well actually a semicircle, but I'm going to imagine that it's in 3D. Alright, so it's coming out the page and going behind the page. If I slice that hemisphere, I'll get like a sort of a cylinder. If I make the height of the cylinder so small, it'll almost be a cylinder. Alright, so if I slice this hemisphere up into loads of cylinders, find the volume of each one and add them all up. That's kind of what we're going to do using integration. Alright, so the volume of one of them cylinders, it's going to be pi r squared h. But in this case, our r is y, so it's going to be pi y squared h, and the height of the cylinder is dx. So it's going to be pi y squared dx. Alright, the volume of one slice. Right, then I can deploy a bit of Pythagoras theory here with this triangle. The bottom's x, the radius of the cylinder's y, but the radius of the whole sphere is r. And using a bit of Pythagoras, I can see that y squared will be r squared minus x squared. Yeah, that. So I've got y squared here and here. So if I substitute this r squared minus x squared into the volume of a slice formula, I'll end up with this. Then I will expand the brackets, multiply through by pi, and I get that. So that's the volume of one slice. Now if I take the integral of it and integrate with respect from 0 to r, that's there, 0 to r, this will give me it'll add up all the slices in this hemisphere and give me the volume for a hemisphere. Alright, and to get the volume of a sphere, I'll just double my answer. So to integrate this with respect to x, it's going to be pi r squared x, pi x cubed over 3. Let's move along and see that. There you go, pi r squared x minus pi x cubed over 3, my limits of 0 to r. Now, when I put the limit 0 in, both of them terms will come to 0. So I can just ignore that and carry on sticking my limit in when it's r. Alright, so what I do there, wherever there's an x, I put an r in, so I get an r there and an r there. Then I'm going to tidy this up. I'm going to multiply the top and bottom of this fraction by 3, just so I can combine these two fractions. And combine them r squared and r, the r cubed. And I end up with this scenario. The volume of the whole hemisphere will be 3 lots of this stuff minus 1 lot of that stuff. Well, that's going to be 2 lots of that stuff then. So I end up with 2/3 pi r cubed volume of a hemisphere. To get the volume of a sphere, I'll just double it, times it by 2, and I get 4 pi r cubed divided by 3, or 4/3 pi r cubed. Alright, so that's how you use integration to derive the formula for the volume of a sphere.